Most people go straight to the textbook trick, but there is another method to integrate secant x, and it's very elegant. The typical method is to multiply the top and bottom by secant x plus tan x, because this makes the numerator exactly the derivative of the denominator. So the integral becomes the natural log of the denominator. But the method I want to present is a little prettier, in my opinion. First, we'll express secant x as the reciprocal of cosine, which it is, of course. And then we'll multiply the top and bottom by cosine x, which is much easier to think of than secant x plus tan x. I'm sure you would agree. We have cosine x over cosine squared, and then we'll use the Pythagorean identity to express the denominator as 1 minus sine squared. And now the substitution becomes very clear. U equals sine x, du equals cosine x dx, so the integral becomes 1 over 1 minus u squared du. Typically, you would factorize this using difference of squares and then have two natural logs. But did you know that the antiderivative of this is a standard result? The derivative of the inverse hyperbolic tan function is 1 over 1 minus x squared. And this is exactly the integrand we have. So, the result will be the inverse hyperbolic tan of u. And now all we have to do is substitute back u equals sine x, and that's it. The integral of secant x is the inverse hyperbolic tan of sine x, plus a constant of integration c. Did you know this?